So hello everyone and welcome back to SWEcodes. I am Kaushal Kumar working as a software engineer on Airbus. So as I have promised, we'll be starting a new series on binary search, and this is going to be the first video of the binary search series. And binary search is a very simple search technique and yet very complex to apply and implement on different problems. So the standard binary search problem is very easy to understand and implement, but when it comes to the complex problems and where binary search can be applied, then there are lots of confusions on applying it and implementing it. So what I'm gonna do is, like, in this series we'll be starting with the introduction of binary search, and I'll be sharing you a very different perspective of binary search with which it will be very easy for you to apply on different complex problems, and you will be able to solve lead code interview questions of binary search using this technique. So let's start. So we'll start with the standard binary search. So you all know what a binary search technique is. So binary search is a technique where at each iteration like you almost ignore half of the search space from consideration, and this way you reduce the search space by half in each iteration. So let's start. So I have a simple problem, the binary search problem on the lead code. It's 704, and let's give a read to this question. So we are given an array of integer nums which is already sorted in ascending order and an integer target. So we have to write a function to search target in this array, and if target exists, then returns its index, otherwise return -1. And we must write an algorithm in order of log and runtime complexity. So what we are given is like a sorted array, and in sorted array we need to find a target, like if this element is present in this array or not. So we all know that with linear search it would be very easy, like just traverse element by element and just check if you have that element or not. So yeah, with linear search we'll just check -1, then 0, then 3, then 5, and then 9. So we got 9, then we'll return the index. So with linear search it will be very easy, but there is no use of this property, the sorted property. So what we are gonna do, what standard binary search tell us to do is, like, I'll just tell you quickly, write in this example. So the example was something like -1, then 0, then 3, then we have 5, then we have 9, then we have 12. So what binary search tells us to do is, like, decide a search space. So our search space could be the 0th index and the last index, and then calculate the mid. So mid will be something like here. So this will be mid, and we have to search for 9. Target equals to 9, so we have to search for 9. So what we'll do is, like, we'll first compare this 9 with this mid. So what we get to know is, like, this 9 is not equals to this mid. So either it could be greater than the mid, or it could be less than the mid. So we know that, like, yeah, 9 is greater than the mid. Then since it is sorted, then we all know that if mid is less than 9, then all the elements from low to mid will also be less than 9. So we'll ignore this half from our search consideration. Then what we'll do, like, we'll update our low value to mid +1. So this will be new low. So this will be rejected, this will be rejected, this will be new low. So again we'll do the same, we'll calculate the mid. So yeah, this will be the new mid, and we'll compare. So 9 is equals to 9. So yeah, we got our answer, and we'll return mid. So it's very simple, like, the standard binary search is very simple to implement. Also, like, what you have to do, you have to just do two things. Like, you have to just, yeah, I'll just scroll it down. Yeah, what you have to do is, like, you just have to simple, once you have your mid calculated, then you just need to compare your target with your mid. If target is equals to mid, that means we got our element. So we need to return this index, sorry, not mid, the array of mid. So we'll just do something like this. Yeah, we need to return this index. If target is less than mid, yeah, if target, sorry, it's greater than mid, Okay, we will do the less than mid also. If target is less than the mid, that means the middle element is greater than the target. That means all the element to the right of mid, that is from mid plus 1 to high, mid to high, will also be greater than mid or greater than target. Then what we need to do is like we need to reduce our search space. So we know that every element from mid to high will be greater than the target. So we need to search target for the left half. So we need to search for the left half. So we'll reduce high to mid minus 1. Similarly, if target is greater than mid, then what we need to do is like we need to increase our low value to mid plus 1. Why we are doing that? Because if target is greater than the mid value, then we know that all the elements from low to mid will also be less than target. So since target is greater than this value, the middle element, then as it is sorted in ascending order, then all the elements to its left will also be less than target. So we need to search in the right half. So this is the right half and this is the left half, and this is the condition where we find the element, so we return the index. So this strategy is very easy to understand for the standard binary search problem, and it's also very easy to implement. So let's try to implement it. So first we need to define our search space. So what would be the search space? Since we are having an array, so the first index and the last index of the array will be our search index, because we are trying to find the target inside the array. So let's define our search index like a dot size minus 1, something like this. Now what we are going to do is like, since until y is less than equals to high, we'll do things. First we'll calculate the mid. I'll tell you why I am calculating mid like this later. It has a certain importance why we are calculating mid like this. We can also do low plus high by 2, but it has certain flaws. I'll tell you later. So what is our condition? If target is equals to the mid element, then we found our element. So what we need to do is like we need to return the index. Otherwise, if target is greater than mid, if target is greater than the middle element, that means we can write else if something like that. If target is greater than the mid, that means is like all the elements from low to mid is also less than the target. So target is also greater than all the elements from low to mid. So we need to search for the right half. This is simple. Else what to do? We covered the condition where target equals to mid. We covered the condition where target is greater than mid element. Then the last condition is when target is less than the mid element. And if target is less than the mid element, suppose this 5 is our mid and we are searching for 0, and 0 is less than the mid element, then we need to search for the left half. So for left half, what we need to do is like our low will be here, our high will be here. So we need, and this is our mid, this 5 is our mid. Then what we need to do is like we need to reduce our search space to include only the left half. To include only left half, what we have to do is like we'll keep our low as it is and we'll reduce our high to mid minus 1. So we'll reduce our high to mid minus 1. So this will this is the basic implementation of the binary search. Otherwise, since we are already covered a condition where target equals to mid element, then we are returning the index of that element. Otherwise, if we do not find target inside array, then what we need to do is like we need to return minus 1. So we'll just return minus 1. Okay, now let's try to hit it and just check. So I'll just check by hitting it. Okay, so let's run. So yeah, it's accepted. Let's try to submit it. Yeah, it's accepted. So So this is the basic implementation of the binary search.